Hello everybody. We're going to start our unit on polynomial functions, starting with just the basics in section 4.1. Some vocabulary that you need to make sure you know. First, a polynomial. Standard form. Everything that we put from here on out should be put in standard form, meaning that we're listing our terms in order from the highest to the lowest exponent value. The degree. The degree is the same value as the highest exponent. So for example, if our highest exponent was x to the fifth, then this is a fifth degree polynomial. The leading coefficient. The leading coefficient is the number in front of that term that contains the degree. So how do we know something is a polynomial? Well, first of all exponents, and the key here is exponents, have to be whole numbers, no fractions, no negatives, whole numbers. And so if it is a polynomial, then we're going to make sure that we put it in standard form. We're going to find the degree and the LC, or leading coefficient. So let's take a look at example A. I have x to the third power and x to the first power. Both of those are whole numbers. So yes, example A is a polynomial. It's already in standard form because I go from the third power to the first power to no x. The third power is our highest exponent. So this is a third degree polynomial, and the leading coefficient, or LC, is -2 because that's our number that's in front of our largest term. Example B, we look at the exponents. I have a 3 and a 4. Yes, we know that this is a -0.8, it's a decimal. Yes, we know that's a radical too, but we don't care about those. We only care about the exponents. And so both of those exponents are whole numbers. So yes, example B is a polynomial. It's not in standard form. These two terms need to swap places. So for standard form, we'd have the square root of 2 times x to the fourth minus 0.8 x to the third minus 12. Now that we're in standard form, our largest exponent is 4, so this is a fourth degree, and the leading coefficient, or the number in front, is the square root of 2. Example C, we have x squared, x to the -1st. Well, I'm going to stop right there. Because of that -1 is not a whole number. It's an integer. And so this is not a polynomial. Example D, our exponents are 2. Oops. What happened there? Sorry about that. 2 and x. Well, we don't know if x is a whole number or not because we can put anything we want into x as far as we're aware. So, because our exponent there is a variable, this is not a function. All right, our next example. We go from a 3 to a 5 to a 2 to no variable. This is definitely not in standard form. So to make it standard form, that negative 6x to the 5th has to come first. That's a positive 4x cubed plus 2x squared minus 1. The 5 says that this is a 5th degree polynomial, and our leading coefficient is negative 6. Example 2, I have 2, 1, 4, and then no variable. This also is not in standard form. We have to rewrite it. That's a negative in front of the x to the 4th, a positive x squared, a positive x, and then plus 9. This is now in standard form. Our highest exponent is 4, so this is a 4th degree polynomial. And the leading coefficient, yeah, there's nothing there except the negatives, but remember there's always a 1. So our leading coefficient is negative 1. Our last example, we have x to the 1st and then 4. This is in standard form. It goes from x to the 1st to no variable. Our exponent is 1, so this is a 1st degree polynomial, and our leading coefficient is 1. Evaluating polynomials. So all this means is to plug in the given value for x and find an answer. Our first example is asking us to plug 3 in for every x in our problem. So that'll be 2 times 3 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7. I plop all of that into my calculator, or I do it in my head, and I get 98. And so when our x is 3, our y is 98. Our second example is asking us to plug in happened there, sorry about that. Plug in 4. So these 3 x's are going to get a 4. And negative 2 times 4 to the 4th plus 6 times 4 cubed minus 3 times 4 plus 11. Plop all that into my calculator and I get negative 129. So G of 4 is negative 129. Third example, this is asking us to plug 4 in for x. So we have negative 4 cubed plus 3 times 4 squared plus 9. I plug all that in and we get negative 7. So when x is 4, the answer is negative 7. Our last example is asking us to plug negative 2 in for x. So 3 times negative 2 to the 5th minus negative 2 to the 4th minus 6 times negative 2 plus 10. Please remember to be careful with your signs. Right here, I cannot do that and make that adding the opposite because of order of operations. Order of operations says we have to do the -2 to the 4th first and then worry about that subtraction. So again, whether I'm doing this by hand or in a calculator, I should get -90. So when x is -2, the answer is -90. The last thing we're going to talk about today, and this is another little piece to the puzzle that we'll be working on and striving for throughout the chapter, which is graphing these polynomials. So we're talking about end behavior. End behavior means what direction are these arrows going at the end? So I'm going to try to simplify this just a little bit. If your degree is odd and your leading coefficient is positive, then your ends are going down to up, -infinity to positive infinity. If you have an odd degree and a negative leading coefficient, then we're up to down, positive infinity to negative infinity. I like to take a look at these and say a positive slope goes up from left to right, so from arrow to arrow, our slope is going up. And then the same thing with the odd negative, from left to right, from arrow tip to arrow tip, we're going down, so it's a negative slope. I don't know if that helps, but if it does, there you go. Then we have even degree and a positive leading coefficient. Then both arrows are pointing up to positive infinity. Even degree and negative leading coefficient, then both of my arrows are pointing down to negative infinity. Okay, so the end behavior, number one, we have to figure out what is our degree and what is our leading coefficient. 4 is our largest exponent, so this is a 4th degree, and our leading coefficient is -0.5. So 4th degree is an even degree. Our leading coefficient is negative, so my end behavior is negative infinity, or down and down. That's what's happening at the end of my graph. Example 2. 3 is our largest exponent, and in front of that is a -1. So this is a 3rd degree, and my leading coefficient is -1. 3rd is an odd degree, and we again have a negative leading coefficient. So odd, negative, our ends will go up on the left and down on the right. Number 3, our degree is 5. So this number 3 is not in standard form. We have a 5th degree, which makes our leading coefficient +3. 5th is an odd degree with a positive leading coefficient, odd, positive, down on the left, up on the right. Example 4. Our largest exponent is 3. So again, this is not in standard form. We have a third degree with a leading coefficient then of 0.25. This is an odd degree with a positive leading coefficient. Odd positive goes down to up. This is where we will stop for section 4.1. We'll practice this tomorrow and then continue working towards our end goal of graphing these. Have a great night.